For the first time in the history of astronomy, humanity has seen a genuinely unprecedented picture. One that is filled with wonder throughout the world of science and sparked the imagination of the people. The James Webb Space Telescope, the jewel of contemporary space exploration, has just produced the sharpest and most detailed photo ever taken of Proxima b, a planet that orbits the nearest star to our Sun, Proxima Centauri. This achievement is not merely a miracle of engineering and optics. It is a revolutionary moment in the pursuit of life beyond Earth and enriches our knowledge of the universe in ways thought impossible before. For decades, Proxima b existed in the world of hypothesis and conjecture, a blip on a chart, a curiosity orbiting a diminutive red star. Now, for the first time, it is a world, a real, visible, and unquestionably present one. As the photo was unveiled, Proxima was no longer a blip on a data curve or a fuzzy spot of infrared radiation, but a world. Solid, textured, defined. Webb's sophisticated near-infrared camera, or NICAM, and the mid-infrared instrument, or MIRI, teamed up to break through the cosmic dust and electromagnetic interference that have long obscured exoplanet sightings. What was revealed was a sharp high-definition picture of Proxima b in stunning detail. There were subtle albedo differences on the surface, bright areas that might indicate ice or reflective desert sands, dark strips that could represent oceans, volcanic plains, or maybe dense cloud cover. There was also stratification in the atmosphere. The spectroscopic measurements showing layers that could act in behaviors eerily close to Earth's stratosphere and troposphere. Polar caps were even visible with icy caps glinting dimly at the hemispheric edges. Though it's still far from the sort of planetary portraits we have of Earth or Mars, this image brings us quite dramatically closer to knowing alien worlds as places rather than concepts. The importance of this image is what it signifies, an instant of cosmic maturity, when theory crashes into observation. Exoplanets such as Proxima b were long known for decades indirectly. They were found by the characteristic wobble of their parent stars or the tiny dimming that happened as they passed in front of them. Whereas these techniques permitted researchers to deduce the existence, mass, and orbital behavior of exoplanets, they created huge voids in knowledge regarding their composition, climate, or surface properties. The James Webb Telescope, through its groundbreaking capability to separate planetary light from the glare of close stars, has changed everything. It's no longer about discovering planets. It's about defining them, studying them, and starting to imagine them as not just blobs and data, but as possible habitats. Proxima b orbits inside the habitable zone of Proxima Centauri, a red dwarf, just 4.24 light-years from us. The habitable zone is the not too hot, not too cold range where liquid water might actually exist on a planet's surface. The planet itself is about 1.3 times the mass of the Earth, squarely within the terrestrial category. Unlike gas giants and ice worlds that account for so much of the exoplanet finds, these qualities alone have made Proxima be a fascinating topic for years. But visibility has always been the challenge. Its closeness to its faint but very energetic star meant that earlier tools couldn't pick out enough detail to say anything conclusive about its atmospheric or surface properties. The Webb photo alters that. It is like having looked at the shadows on the wall for years, having finally turned one's head in order to catch sight of the source of the silhouettes. The telescope's sophisticated coronagraphs and photometric filters allowed astronomers to block the starlight of Proxima Centauri with unprecedented accuracy so that they could peer at the soft reflected light of the planet alone. What they discovered were absorption lines in the atmosphere indicating the presence of crucial compounds, carbon dioxide, perhaps water vapor, and tantalizing suggestions of methane. Although none of this proves the existence of life, the chemical signals are in agreement with environments that at least are not inhospitable to life as we know it. There were also temperature measurements based on the thermal emission data, showing moderate surface temperatures that are within the limits of Earth-like conditions. The mere existence of the possibility to detect such chemical fingerprints over more than 4 light-years of space is a testament to human engineering as well as the collaborative accuracy of Webb's instruments. Aside from the short-term implications for astrobiology, this photo of Proxima b provides a glimpse at what Earth-like exoplanets may actually appear. The terrain looks modeled with areas of increased reflectivity, possibly being signs of ice or desert-like plains. Darker regions that can be matched to oceans or cloud-shrouded areas exist. Even the reddish color of the faintness of the planet, probably due to the light of the red dwarf star, provides an otherworldly familiarity, alien yet strangely understandable. For both planetary scientists and artists, this visual backdrop sets a new standard of reference for projecting what other rocky exoplanets will be like. Abruptly, when conceptualizing alien worlds in literature, movies, or simulations, authors have a tangible reference to draw from, not mere conjecture. The buzz that this image has caused comes not so much from what it reveals, but from what it demonstrates is now achievable. Taking a picture of an exoplanet at such precision is a benchmark for observation astronomy. It proves that with the proper instruments and methods, even planets around far-off stars can be resolved and examined in unprecedented detail. This promises a broad range of research prospects, ranging from exoplanetary climate modeling to planetary evolution studies and other star systems. It also makes the quest for extraterrestrial life much more concrete. Instead of guessing from indirect clues, scientists are now able to study real planetary conditions. For a discipline long resident in the realm of inference and possibility, this move into the realm of visual science is tantamount to a new dawn. It is also an instant of deep philosophical significance. For over 3 centuries, the question of whether we are alone in the universe has troubled our kind. While we have discovered microbial life to be incredibly resilient on Earth, surviving in acid lakes, ice tundras, and scalding vents, the application of that resilience to other planets has been speculative. With this photo, the space between speculation and observation grows narrower. If Proxima b planets are this Earth-like in the visual and chemical sense, it means the ingredients for life might not be as scarce or exotic as once thought. Abruptly, the darkness of the night sky seems less vast and more like a room full of possible roommates. Additionally, the detail that was gained from one of those stars orbiting a red dwarf is a compelling indicator of the ability of Webb. Red dwarfs are the most numerous stars in the galaxy, comprising around 70% of all stars. If worlds orbiting such stars are able to be visualized at such a high resolution, it means that there are exponentially more worlds that could be observed as habitable. Webb's achievement in imaging Proxima b provides a model for observing other likely candidates like those in the TRAPPIST-1 system or LHS 11140b, further opening our universal vistas. It flips the equation. No longer do we have to envision habitable worlds as scattered jewels in an otherwise barren universe, but rather perhaps relatively common events in the cosmos. Perhaps most intriguing about this success, however, is the interdisciplinary nature of the endeavor. Astrophysicists, engineers, chemists, planetary scientists, and computer scientists were all involved in developing the imaging algorithms, calibrating the equipment, and analyzing the data. The Webb picture is as much a success of data science as optics. Machine learning techniques were employed to restore the light from the planet that is so faint it's masked by noisy data to the point where the resulting image has to be accurate and high in information content. This bringing together of human brains from diverse fields shows that space exploration is no longer the province of standalone disciplines. It's more of an orchestra of knowledge playing together. It is hard not to think of the magnitude of collaboration involved. Hundreds of minds on continents pouring into a single image of a distant world. The release of the image also revives interest in space science in the public. Visualization has an emotional impact. Glimpsing a distant world with our own eyes, even through the eye of a space-flying telescope, makes the universe slightly more accessible. The picture of Proxima b with its Earth-like outline and enigmatic surface markings doesn't only exist in scientific publications. It's part of our shared imagination. Now, schools, planetariums, museums, and social media are already capitalizing on it to motivate the next generation of scientists, engineers, and dreamers. For young kids looking at the picture, the concept of being part of human history's quest for the stars might no longer be such a distant dream, but something within reach. That change of mindset transforming far-off potential to near-hand actuality could be as significant as the science. Technically speaking, the accuracy of this sighting is the result of decades of advancement. Webb's mirror calibration, thermal control, and adaptive optics all needed to work perfectly to bring this about. The telescope needed to account for both the immense distance to Proxima Centauri and the high-speed orbital motion of Proxima b within its star. Predictive tracking, algorithms and on-the-fly calibration were needed to prevent image blurring. The data acquisition was done over several weeks, taking several orbits so as to verify consistency and reduce the impact of stellar flare activity, a natural phenomenon associated with red dwarf stars. Every photon accounted for, every calibration was crucial, and every line of software that directed Webb's instruments had to execute flawlessly. These milestones, remarkable as they are just the start. Researchers now are applying the information to create three-dimensional simulations of Proxima B's surface and climate. These simulations will be used to estimate the planet's rotation dynamics, atmospheric circulation patterns, and potential for generating magnetic fields. All key considerations in determining long-term habitability. If the planet does have a magnetic field, it would provide defense against the common stellar flares that Proxima Centauri emits, giving it an even greater possibility of harboring life. Even the planet's axis tilt, its seasonal forces, and the flow of its winds are now matters of educated debate, not blind conjecture. The implications for missions in the future are momentous. With the success of Webb's imaging of Proxima b, discussions have intensified around launching dedicated interstellar probes. Projects like Breakthrough Starshot, which aims to send gram-scale spacecraft to nearby star systems using laser propulsion, now have clearer targets and more precise mission parameters. Knowing what Proxima b looks like, what it's made of, and how its atmosphere behaves will guide the design of instruments and trajectories for these missions. The dream of dispatching robotic probes to the neighboring star systems is no longer science fiction. It is a strategic objective based on hard facts. Generations that would grow up with science fiction tales of other worlds and alien civilizations may live to witness spacecraft hurtling through the emptiness to pay a visit to one. This picture of Proxima b is not merely another milestone in astronomy. It is a milestone, a moment when mankind made the leap from guessing to actual sight, from circumstantial inference to concrete evidence, a reminder that the universe is not out of our grasp, and that with perseverance, technology, and cooperation, even the farthest worlds can be brought into view. The question of life on Earth still has no answer, but with every new find, the answer seems nearer. The universe has shown us a glimpse, and then it is our turn to see where it takes us.